Hello and welcome once again to another lesson, Images from Space. What is electromagnetic radiation? Energy traveling as electromagnetic waves is called electromagnetic radiation. Wavelength. It is the distance between two adjacent crests or troughs of a wave. Frequency is the number of waves per second. If you look at this picture, you can see that the wavelength is from one crest to another crest or from one top to another top of the wave. You can think of it as the top of mountains. So from one top to another top is what we call the wavelength. But it can also be from the bottom to another bottom or from the trough to another trough. That is also considered to be wavelength. And frequency is the number of waves in a given time or second. So basically, the number of waves passing in a given time is the frequency. How is electromagnetic radiation classified? All wavelengths or frequencies make up the electromagnetic spectrum. What is a spectrum? A spectrum is a continuous range of a single feature, in this case, a wavelength. This is the electromagnetic spectrum. As what you can see, from the left to the right, this is the correct order of increasing frequency and energy. Radio wave, microwave, infrared, visible light, ultraviolet light, X-ray, and gamma ray. If you're going to look at the size, this is the comparison. This is how we can be able to picture out the size of each electromagnetic wave. So the radio wave is about the size of buildings. Microwave is about the size of grains of sugar. Infrared about the size of protozoans. And visible light about the size of bacteria. Ultraviolet light about the size of molecules, X-ray atoms, and gamma rays, atomic nuclei. By the way, these numbers tell us the size itself. So this is in nanometers. So when we say nano, it means billionth or to the negative 9 power. So radio waves have 1 nanometer size and so on and so forth. And if we are going to look at the uses, so for radio waves, they are used to broadcast radio and television. Microwaves, they are used in cooking, like the microwave that you are using to heat your food. Radar, telephone, and other signals. Infrared, they are used to transmit heat from the sun, from fires, or from the radiators from your cars. Visible light makes us see things or make things able to be seen. And ultraviolet light absorbed by the skin, and they are also used in fluorescent tubes. X-rays, they are used to view inside of bodies and objects, and gamma rays, they are used in medicine for killing cancer cells. How is electromagnetic radiation classified? Radio waves are the longest wavelength, lowest frequency electromagnetic waves. Microwaves have shorter wavelengths and higher frequencies than radio waves have. Again, you have to remember that the longer your wavelength is, the lower is your frequency and your energy is. They are indirectly proportional. The length and the frequency and the energy. Infrared waves have shorter wavelengths and higher frequencies than microwaves have. They are sometimes called heat radiation, as what you have learned from the previous example. So then again, the shorter your wavelength, the higher is your frequency and your energies. Visible light has a shorter wavelength than infrared has. Visible light allows you to see. Ultraviolet radiation, X-rays, and gamma rays have increasingly shorter wavelengths, which makes them have greater frequency and greater energy. What are some characteristics of electromagnetic radiation? Different types of electromagnetic waves interact with matter differently. Objects can give off heat, light, and other forms of electromagnetic energy. For example, physicians use X-rays to examine the inside of the body. What are some characteristics of electromagnetic radiation? In small amounts, electromagnetic radiation can be very useful. However, in large amounts of any type of radiation, it can cause problems because of the total amount of energy carried. What are some characteristics of electromagnetic radiation? So this is just a review of what I have discussed to you. Describe the differences between the various forms of electromagnetic radiation. In the atmosphere, atoms and molecules reflect or absorb some of the incoming radiation. Most visible light and radio radiation reach Earth's surface. Some ultraviolet radiation reaches Earth. X-rays and gamma rays never reach Earth's surface. Again, remember, X-rays and gamma rays never reach Earth's surface. Just like what you can see in this picture. What type of electromagnetic radiation reach Earth's surface? So you can see radio, microwave, infrared, and you have the visible light and ultraviolet light. But most of the waves that reaches that reach Earth's surface are radio waves. That's what you can see in the picture. How do people detect electromagnetic radiation from objects in space? Images of objects in space tell us about their positions and properties. Telescopes can collect all forms of electromagnetic radiation from space. Special detectors in telescopes must be used to form images from radiation other than visible light. How do people detect electromagnetic radiation from objects in space? Optical telescopes collect visible light with a mirror or a lens. A telescope that uses a mirror to collect light is called reflecting telescope. Again, if it is used to collect light, then it is a reflecting telescope. A telescope that uses a lens to collect light is called a refracting telescope. Again, you can see the difference. If this telescope uses a mirror to collect light, it is a reflecting telescope. And if it uses a lens to collect light, then it is called a refracting telescope. So from the word reflect, it bounces off the light, and from the word refract,